Okay, this video introduces the basic concept of blockchain and cryptocurrency. For the second week of this course, let's look at the basic technology that implement the blockchain system, and the basic technology include cryptography and the distributed consensus algorithm. So during this week we focus on the main two technologies. The one is cryptography and the other is distributed consensus algorithm. Okay, let's move to blockchain technology 1, cryptography. The cryptography is the technology that encrypt plain text and the reverse direction, ciphertext to plain text is decryption. So encryption means the change plain text into ciphertext, and the decryption process transforms ciphertext to original plain text. So this encrypt-decrypt process, there are two types of keys used in cryptography. There is secret key. The one is a symmetrical key. The other is asymmetrical key. In the symmetrical key cryptographic systems, the same key, secret key, is used to encrypt and decrypt. So both processes use the same key. That is symmetrical key cryptography. On the other hand, asymmetrical key cryptography used two different keys. If the that is public key and the private key. If the public key used to encrypt the plain text, then the decryption process, which change ciphertext to plain text, must use private key. So encryption process and decryption process use different keys. Okay. So asymmetrical key cryptography use both public key and private key. Okay. Okay, let's see the history of the symmetrical key cryptography. During World War II, German developed Enigma. That encrypt the plain text into ciphertext. And decrypt the ciphertext and the plain text. So German military forces use this machine to encrypt their commands, world control information, and send the encrypted command. So the England had a difficulty in gathering the command information, monitoring the Germany's command. So the England mathematician, he's from Cambridge University. His major is mathematics. Alan Turing developed Colossus. The government, United Kingdom government, support him to develop this Colossus machine. The Colossus machine use 1,800 vacuum tubes. By that time, the vacuum tube is the only device that can describe binary information, 1 or 0. This vacuum tube is replaced by transistor later. Okay. So the 1,800 vacuum tube function same as 1,800 transistors, but the space is very big. You see the figure of the Colossus. This Colossus invention is prior to ENIAC computer. The first general computer developed by United States. So United States Army. You see the movie of the imitation game. Okay. The main actor performs Alan Turing. Unfortunately, Alan Turing died in 1940. In he's 40 years old. But now, to memorize him, the world created the Alan Turing Award. So annually select best person in information communication technology area, and this honorable Turing Award is given. Okay. A symmetric key cryptography is also called the public key cryptography system. TP and Hellman developed the Deep-Hellman key exchange method. The Deep-Hellman key exchange method based on the R&D reports by Ralph Merkle. In the blockchain technology, you see the Merkle tree. The Merkle tree, that Merkle is this Ralph Merkle. But now the Deep-Hellman is famous instead of Ralph Merkle. But the basic technology, the Ralph Merkle invented it. So 2015 Turing Award was given to TP, Hellman, and Merkle. Three persons. Okay. So now, right side, you see the figure, photo of TP. With the mouse touch, that is TP and Hellman. So Hellman is Jewish. He's from Stanford University. His major is electrical engineering. The DP is from MIT. He major mathematics. So 1977 MIT developed RSA Public Key Cryptography technology. The RSA Public Key technology, cryptography technology, based on Deep-Hellman key exchange. Okay. Mathematics is very important in the asymmetric key cryptography system, RSA Public Key System. Let's see the principle of RSA Public Key System. Mathematically, for the very large random number, key generation program produce two different keys, public key and private key. Each key consists of two integers, very big integers. Okay. This example shows public key consists of 5 and 14, private key 11, 14. Actually, this integer number is very, very big. Okay, so the enemy is almost impossible to find this integer. It's very, very big integer. So the algorithm use public key. So if the hello message, so in the RSA public key system, all use mathematics. Mathematics is number theory. So message is represented by numbers. Key is represented by numbers. The encryption algorithm, for example, message hello is represented by 2, then 2 to 5, mode 14, result in 4. So 4 is encrypted message for the hello message. So hello message is represented by 2. The encrypted message of hello represented by 4. So encrypted message 4 to 11 mode 14. Compute 2. So 2 is hello. So the encryption process use public key, 2 integers 5 and 14. Decryption process use private key, which consists of 2 integers 11, 14. So a symmetrical key encryption, decryption use mathematics, real number theory. Okay, let's see the terminology used in the blockchain and cryptocurrency. Okay, transaction, we usually call it TX.
우선 아이폰을 잠금 해제하셔야 합니다.
Okay, so to transfer money, the TX must be composed, and the TX is sent to all miners. Once a certain amount of TX is gathered, all the miners competitively start to do mining process. That is proof of work. Once a certain miner succeed to create a block, then the block reward is given. Then the new block is sent to all the nodes, all the other nodes, including mining nodes. So each node, when each node receives the new block, they first check whether the proof of work was successfully done. It's easy to check block hash value. One try of the hash function can verify whether the block hash was correct or not. Okay, so then after each node verify the new block, if the block is valid, then they extend the new block. So the blockchain is extended. So you need to be familiar with the terminologies. Address. Address is same as the bank account number. Okay, and the transaction. And block. So miner and the blockchain. In cryptocurrency, private key, public key, hash function, and address. They have close relation. Okay, so from random number, algorithm generate private key and public key. Is a pair. From public key, hash function. That means the public key is input to hash function. So hash function generate address. Okay. Here, hash function is irreversible. That is directional. Okay. You can produce address from public key, but reverse direction you cannot. Public key from address. Hash function is irreversible. So user wallet can contain multiple private keys. That means user can use multiple address. Multiple address. Okay. So user maintain and securely store the wallet, because inside the wallet there are private keys. So handling the private key need to be careful, very careful. So the exchanges, Bitcoin exchanges, okay, they store users' private keys on behalf of users. Okay. Let's look at transaction. Okay, transaction usually consists of input and output. Okay, input can be multiple. Also, output can be multiple outputs. Okay. Every input the owner of this transaction need its signature. So from some accounts, if he or she want to withdraw some bitcoins, he need a signature. Signature is the private key. Private key is necessary to sign this transaction. So private key is used to make the input. Also, the output the destination account number, so it's related to public key because the account number is derived from destination public key. So transaction consists of input and output. So the private owner can only create the transaction, okay, because the transaction needs a signature. So if the private key is lost, he loses all the bitcoins for this account. Okay. On the other hand, block is created by the miner. Okay. So miner gathers transactions data. Here data stands for transactions, gather the transactions, and then data nonce hash of the previous block is our input of hash function. So try hash function until the block hash value satisfy the block difficulty level. So it means the hash value must be less than certain size, certain number. Once the block is created, miner succeed to obtain the block hash value which is less than a certain number. The block was sent to all the nodes in the networks. Okay, blockchain is the chained blocks. So every block in its block header contains the hash value of a previous block. So blocks are linked. Okay. So you see the data and the nonce and the previous hash produce block hash value. So if the data is attacked by enemy, then the block hash changes. Then for the next block, previous hash value is different from the block hash of the previous block. So attack to blockchain is very difficult. Okay. Let's look at the features of blockchain. Blockchain is distributed database. Every nodes the mining node can add a block. Also anyone can add transactions into block. Once the transaction is contained in the block, no change allowed. So this blockchain technology make the financial system borderless. Also, the open means anyone can add its transactions into block. So open financial networks pseudonymous. Only using its private key, public key, and address. You can use the open financial networks. So this blockchain service is censorship resistant, immutable, irreversible. So the payment transactions, censorship resistant, immutable, and irreversible. Okay, let's move to next important technology to make a blockchain possible. That is distributed consensus concept. Okay, distributed consensus, same concept as distributed computing. Okay. Proof of work, mining, block creation. All of these functions are needed to implement distributed consensus. The origin of distributed consensus came from Byzantine generals' problem. Byzantine Empire is the East Roman Empire. Let's assume 10 generals are distributed in the Byzantine Empire. Each general has military power of 100. They want to collaborate to attack some castle. But the castle has the military power of 800. So minimum 8 minimum 9 generals out of 10 has a consensus about attack operation, attack plan, then they can collaborate. The military power, total military power from generals must be greater than 800 to win the enemy. Now, how can they communicate? How can they send the attack plan? The attack plan the soldier can be captured and can be killed during his way to visit other generals to send the message of the attack plan. Then how they can be confident whether they can collect minimum of 900 military power. Okay, this is the Byzantine general's problem. Okay, this X is the attack plan information. All the generals must come to know the attack plan X. Also, all the generals should know that the fact that all the generals know the information of X. Also, all the generals knows the fact that all the generals know the fact X. Confusing. Solution is proof of work, POW. Okay, let's solve some mathematical problem. let each general to solve a mathematical problem. Once a general succeed to solve the problem, the general send the solution, answer, to every other generals. Then let's assume the solution usually takes 100 minutes in average. Then the generals, they competitively solve a series of problems. Then if 10 generals involves to solve the problem, mathematical problem, each general will receive the answer every 10 minutes because 10 generals involves to solve the problem, mathematical problem. Each problem, it takes 100 minutes for a general to solve. So 10 generals, if 10 generals involves to solve the solutions, then every answer will be propagated every 10 minutes. Okay. So the block contains the answer. So if each general receives the answer block every 10 minutes, it means that 10 generals now agree on distributed consensus. Okay. Okay. If each general succeed to solve the mathematical problem, then the block hash is same concept, of the solution. Answer. And data is attack plan. And the hash of the previous block is the previous answer, or previous solution, for the previous question. So this block, if this block is generated every 10 minutes, each general has competent 10 generals agree, maintain consistency in attack plan information. Okay. So a series of blocks linked by way of chain. So once enemy try to modify the data in the block, he must change the block hash. So the next block indicate the previous block hash. So that anyone who want to modify data should invest all the computing powers, the same computing power as the whole power the miner invested. Okay. So because of the proof of work, all the 10 generals maintain consistency in the attack plan. So this is called distributed consensus. So the blockchain is based on the distributed trust concept. There is no central authority in blockchain system. Anyone who want to add his transactions in the blockchain, he can. This is permissionless network. Okay. Now this is end of the second week study about blockchain basic technologies, cryptography and distributed consensus. Thank you.